This is Advanced Math, Unit 10, Lesson 5. Okay, we are continuing to sketch today, sketching top-heavy graphs. And we did talk on the previous lesson that that's what we would be doing, sketching top-heavy. Okay, number 1. Y equals x squared minus x all over x plus 1. X squared minus x all over x plus 1. Okay, D for domain. Va, this time we're going to have ha and sa. Va, ha, sa. Domain, vertical asymptote, horizontal asymptote, slant asymptote. X-intercept, y-intercept. Okay, these, I like these. These are a little easier. You don't have to do the test values on these either. And we are going to fill all of this in. Domain is all reals, such that x cannot equal whatever makes the bottom 0. X cannot equal -1. I'm going to factor just to see if anything reduces, and it's going to help me in the later steps anyway. X leaving behind x minus 1 over x plus 1. Nothing does reduce, but it'll help me find my intercepts. Okay. Vertical, I take what makes the bottom 0. X equals -1. Remembering the multiplicity, it's coming from a power of 1, which means it's odd. Horizontal asymptote, I take the limit. It's top heavy, which means it does not exist. And you actually write that down, D and E, which means there is a slant. Horizontal and slant never coexist. They don't happen at the same time. You either have a vertical with the horizontal or a vertical with the slant. You never have the two of them together. Okay, how do you do the slant? Slant, you do long division. All right, so let's get that in. I'll squeeze it in over here. Slant, you do long division, and you're like, oh my goodness, but it's not that bad on the original one, of course, not the factored one. And we do not care about the remainder, ever. And it should always come out to be a linear function. Okay, x times what is x squared? That's x distribute. X squared plus x. And I'm going to change my signs. Minus and minus, gone. That's -2x. And then you start over. X times what is -2x? That's a -2. Distribute, -2x minus 2. And this rest of the step is really unnecessary. Change. Left with 2, but I said earlier we're not going to worry about the remainder, so you don't have to do that last step. This is what I care about. And remember, it's going to be y equals. Horizontal slant are always y equals. Vertical is always x. Y equals x minus 2. So as I stated earlier, it should come out to be a linear graph. X-intercepts, you make the equation equal to 0. The bottom is going to cross out because when you multiply both sides by the denominator, leaving behind 2 x-intercepts, 0 and 1, and they're both crosses. 0, 1, cross, and cross. Your y-intercept, you plug in zeros. Y equals 0 over 0 plus 1, which is 0. So 0. And I've said this before, if your x-intercept 0, your y-intercept has to be 0. Okay. Let's go ahead and try to graph this. All right, came out a little wonky. Okay. My asymptotes, vertical, x equals -1, dot it, and put a little note at the top that it is odd, which means opposite direction. and horizontal, none, slant, y equals x minus 2, y-intercept of -2, and a slope of +1. So up 1 over 1, up 1 over 1, and dot, dot, dot it. Okay, so do you see how it's a slant asymptote? Okay, so I still have two pieces to my graph. I still have the left side and I still have the right side. I still have the top and the bottom. The top is this bigger section down here. The bottom is this smaller little corner down here. On the right side, the top and the bottom. Okay, I'm going to use my x-intercepts. I don't have to do test values. My x-intercepts will be enough. X-intercepts are 0 and 1, and they are both crosses, and my y-intercepts here, I already have it marked. Okay, so left half. Since I have no x-intercepts here, I have to be down in this little corner, because if I was up here, remember they always go towards the asymptotes. If I was up here, I would cross the x-axis, and I can't do that. So I'm down here. Odd means opposite direction, which means I'm coming from here, and I have to go through those 2 points. And, oh, went through a little too soon. And I have to touch, or approach, not touch, the asymptote. So I come down, come up here, and approach the asymptote. Okay, so do you see bounce? That is not a bounce. It comes down and then back up. Do you see there's a little bump there? Comes down and then back up. And that's it for that graph. Okay, number 2. Y equals x squared minus x minus 2 over x minus 1. D va ha sa. Even though you're never going to have ha and sa together, I do want you labeling them all from now on. X-intercept, y-intercept. The test will be that way, just like this, and you're going to fill it all in. One of these will always be none, horizontal or slant. Okay, domain all reals such that x cannot equal 1, because that makes the bottom 0. I am going to factor to see if anything reduces and help me find my intercepts later. Over x minus 1, x minus 2, x plus 1. Nothing reduces, so my vertical is x equals 1. And it's coming from the denominator right here. Remember, it always comes from the denominator. And the multiplicity is 1, which means it's odd. Not because of that 1, because of the power of 1. Horizontal, the limit as x approaches infinity, it's top heavy, so it does not exist, which means there must be a slant, because top heavy is when I do my long division. So I'm going to squeeze it in down here. Remember, I do the original, not the factored. X minus 1 divides into x squared minus x minus 2. And because of time, I'm going to let you do that on your own. Hit pause, long divide, do all your work. You don't care about the remainder, but I'm going to do it. I'm not going to do it all. I'm just going to give it to you. It's x. Try it on your own, and if you didn't get x, ask questions in class. So y equals x, which is equivalent to y equals x plus 0, just reminding you. X-intercepts, you take this and make it equal to 0. The bottom's not going to equal 0 because you multiply it to the other side, leaving behind +2 and -1. Both have a multiplicity of 1, which means they are both crosses. I'll put little C's here for cross and cross. Y-intercept, you plug in 0, 0 minus 0 minus 2, over 0 minus 1 is +2. You can write that down if you'd like, zeros minus 2, 0 minus 1, and graph. Okay. So let's plot our, or graph our vertical. X equals 1. And we have a slant, y equals x plus 0. That means your y-intercept is 0 and your slope is 1. Okay, we have two halves, left half and right half. On the left half, we have this bigger top corner. Actually, it starts over here, the bigger top corner, or the smaller bottom corner. And over here, I have the itty bitty top corner up here, or the bigger bottom corner down there. Okay, x-intercepts are 2 and -1, 1, 2, and -1. And y-intercepts are 2, 1, 2. Okay, so when I'm on the left half, you can see that I'm obviously going to be in the top half because I have 2 intercepts over here. If I was at the bottom half, I would stay down here, and I don't have any y-intercepts down there to be crossing, and I need to hit those eventually. So I'm going to be like this, approaching the asymptotes on both sides, or that top one and that bottom one, like that. Okay, now we said earlier that x equals 1 was odd because of the multiplicity right there, which means opposite direction. So I'm coming from the bottom, which makes sense because I have an intercept down here to cross. It's not a bounce. So I cross, and when I cross, there's nothing, no other intercepts bringing me back down. I approach like that, and that there is your graph. Okay, this last one I'm going to give you, you're going to try it on your own. This is a review. It's not one of the ones, the top heavy graphs. It is review. It is y equals 3x plus 1 times x minus 2 over x plus 2, x minus 2. And I say it's review because it's not, it's one of the ones we did in a previous lesson. So try it. I will tell you this, there is a hole in this graph. Try it, see if you can figure it out. You can see right here that it reduces, but remember, you find your domain before you reduce. Everything else comes after reducing. Okay, so find your domain, reduce, everything else comes after. Try it, see if you can figure out the hole on the graph piece, and we'll discuss this one in class. That is it for this lesson.